Hello and welcome to the Solarbotics soldering demonstration. Today we'll be teaching you the basics of soldering, where we're going to attach small electrical components together onto a perf board and teach you the basics so that you can build your own kits at home. The tools we'll be using today consist of a soldering iron that we'll have set to 320 degrees Celsius or 600 degrees Fahrenheit. We'll be using a wet sponge as well as a brass sponge. The brass sponge is nice because it has a flux coating on it. These are both from Hakko. We will be using lead-free solder. We will have our safety glasses, third hand, which makes it very handy for holding your parts, and the individual components that we'll be soldering together. We are asked quite often whether or not fume extraction is necessary, and the answer is it's not a bad idea. Typically, you want to be working in a well-ventilated area. However, sometimes it's hard to find yourself in a well-ventilated area. In these cases, it's oftentimes a good idea to use a fume extractor or an air cleaner. We sell both of these products on the Solarbotics website. Both products will do a good job of working in a small room or a typical workshop type environment. The operating temperatures of your soldering iron are typically between 320 degrees Celsius and 400 degrees Celsius, or 600 degrees Fahrenheit and 750 degrees Fahrenheit. At these temperatures, the flux will turn to smoke, and that's the smoke that you see come off of the part whenever you solder. You don't want to be breathing this in, and that's why having the airflow is a good thing. To get started, one of the first things that you're going to want to do is hold your piece. There are several different types of third hands that are available. Some are a clamp, others are a suction device, and the ones that we like are the SparkFun clamps. These are our third hand, rather. These are very nice because they hold your workpiece right in front of you at the proper height and angle, and you can change it as you see fit. This allows you to clean it with either using a little bit of rubbing alcohol if you see fit. This typically isn't required for a new product just out of the package. It's only really whenever there's contaminants that you're worried about getting wetted into the joint. So you would clean it with, like I said, alcohol, wire brush, and when you have a nice clean surface to work from, when you do your soldering, you want to be cautious that it doesn't draw down into the joint. Flux is actually a nice part of the solder because it is actually a mild acid and will help you a little bit cleaning off the oxidization. It's not good for large contaminants, and that's why the rubbing alcohol is a good option. Instead, it's good for the typical oxidizations that build up just in the package as being exposed to the air. One of the other things that the flux actually does is it changes the surface tension of the solder. If you add flux ahead of time to the joint that you're going to solder, it will thin the solder and cause it to be drawn down immediately into the component that you're trying to solder. So tinning the tip is the process where you add a little bit of solder to the tip. This helps transfer the heat and increases the quality of your solder, because if you do not tin the tip, when you apply the heat into the two parts, it's possible to unevenly heat the two parts, and it's possible that you could create a cold solder joint. To tin the tip, you take a little bit of solder, you clean the tip of your soldering iron using again the brass sponge, and you just add a small amount of solder to the end of the iron, and you'll see a little bit of smoke, and that is the flux. Because of the increased heat, tinning the tip also prevents oxidization. This has the same effect on the wire as well, because again, as you increase the heat, the oxidization process on both metals will increase drastically. To tin wire, it's a very similar process. You just strip back a bit of the wire, expose the wire underneath, you take your solder, and you add a small amount of it to the wire. And this will allow it to join to other soldered components much easier, because it's already been prepared with a little dab of solder on the end. You want to ensure to heat your part for 1 to 2 seconds prior to applying additional solder. You also want to apply the wet of the solder to both components to ensure that the heat transfers evenly. Then apply additional solder to the opposite side, because the solder will wick towards the heat. I'll demonstrate that for you again. 1 to 2 seconds, and apply additional solder. And so the solder immediately jumps over to the heat. Do not overheat, because if you do, you can actually cause these traces to lift off of the board and ruin your project. When you are soldering, you need to remember, once you've soldered your component, to remove the solder first and then the iron. If you don't, what will happen is you will end up with your solder being stuck to your part and not able to remove it. Common aftercare techniques usually include things like you can tin the tip just prior to putting it away. And the common thought is that that will actually prevent oxidization. The thing is inside the center of the wire, there is actually flux in there, which, as I explained earlier, is a mild acid. And placing it against the tip over a long period of time can do damage. I personally prefer to put the tip away dry, having wiped it on a dry sponge, and then wiping it on a wet sponge, resulting in a nice clean tip that may potentially oxidize, but I can then give it a cleaning right before using it, as I'm supposed to anyways. Cleaning the board afterwards is another aftercare technique. What will happen is that same flux that's inside the center of the solder will actually build up on the board, and you'll end up with little brown stains. Those stains are actually good to clean off because, as I mentioned, this is a mild acid. So cleaning it off with an alcohol solution and wiping it down, getting rid of that leftover material is a good idea. It will keep it clean and increase the longevity of your board. Some flux that comes inside the center of this wire is actually referred to as no clean or water soluble. You have to see the manufacturer's instructions to determine which option is best. But the no clean does not need to clean up afterwards. I have found sometimes it doesn't hurt to give it a cleaning anyways. I think more to the point what it's telling you is that it will not eat away at your board if you just leave it there. If you look at these first three solder joints, you can see that they do not cover the entire copper pad entirely. This is not good because it can result in a missed connection, or later on it could result in a fatigued connection as a result of vibrations. In addition, you have here these two joints which were joined together, which will create a dead short. If, for example, these contained power, we could do serious damage to the board. This joint, far too much solder has been applied to it, and you can see that it actually bulges at the side. You're better to have what would look like a volcano, where the peak, from the peak, it indents as it goes down to an even surface below. In addition, here you can see this is not making contact with the copper at all, resulting in a cold solder joint. The other way to tell cold solder joints is if you can see that these are shiny. If you see a matte finish, often that is an indication of a cold solder joint. Here's an example of something not to do. Do not apply solder and then attempt to solder your joint by wiping it off. You will inadvertently transfer solder to more than one point that you do not want solder on. In addition, you will not get a good coating on the entire copper pad, resulting in a poor connection or something breaking later on. The other thing you do not want to do is you do not want to heat at the top of an object to apply heat at the bottom. While this might work, what will happen is the heat that's transferring down here will also transfer to the other side of the board, potentially damaging the component that you're trying to solder into place. A good example of soldering would have you tinning the iron, placing that wet tip into the two parts, waiting 2 seconds, and then applying a little bit of solder. Once you remove the iron, if you're able to do all of this very quickly, this will result in that part not overheating and potentially destroying the component. Some microprocessors are very, very sensitive to heat, and overheating them can cause destruction. When soldering, it is best not to consistently reheat the same part over and over and over again. This can result in the part becoming brittle, the pad lifting potentially, and solder getting into areas that it's not meant to. In addition, over time, the tip may start to look distorted and black. If this contaminant stops coming off of the tip, you can actually clean it using a compound called tip tinner. Tip tinner is used for multiple different purposes, but one of them is recovering an old tip. If you take your tip that is no longer collecting heat properly and you expose it to it and move it around 100%, covering the tip, getting a good coating on there, and pull it out, and then wipe it on your sponge or on your copper pad. You should then have a nice, clean, shiny tip that is able to be used again. Thank you very much for your time. I hope this has been a very helpful instructional video. Please check us out at solarbotics.com.